friends, welcome to Genius Books. I am Vinod Kadkor, IAS Monk. Today I am starting this MathMagics part 2. In this episode we are going to look into some more beautiful things, some tricks. Here you can see one Mr. Carl Friedrich Gauss. He is a German mathematician. I will talk about him later. But see, today what we are going to do in this episode is we are trying to find a sum of any number of consecutive odd or even numbers. Okay, like 1 plus 3 plus 5 plus 7 up to 999 or something, n number of terms. Okay, similarly, n number of, or say from up to 1000, the sum of all consecutive even numbers. Consecutive means there is no gap in between, continuously one after the other, all even numbers. Okay, up to 100, up to 50, up to 1000, up to 10,000, up to 1 lakh. So how we can find these sums within a fraction of minutes? Okay, so with this respect, this wonderful person, wonderful mathematician, Carl Friedrich Gauss, he is connected to this trick. Let us straight away jump into find out how we can do this. Before that, in my previous episode of MathMagics 1, we talked about odd numbers and even numbers. Okay, what was the trick found there? So trick was when we add two. I'm just repeating this, okay? By repeating or by revising, you can become more perfect, okay? To retain that memory or whatever it is, retention power, you have to revise the things often, okay? You have to keep revising every day. Then only you will become perfect. So it is a kind of revision. We talked about Pythagoras knows how the point, straight line, triangle and square were represented by different geometrical shapes, and 10 how it was represented by a circle or sphere by Pythagoras. All that we saw in our first episode. So now, and there I gave you some hint about even and odd numbers. Let me take this example, how we can apply the tricks. What I am going to tell you is, first I will teach you those tricks, and we can apply those tricks on various problems asked in various competitive exams. Okay, fine. This particular question is asked in 2023 Civil Services Preliminary Exam, Paper 2, popularly known as CSAT. So this problem is based on our trick of even and odd numbers. Okay, so there are 3 of the 5 positive integers p, q, r, s, t are even. So p, q, r, s, t are the given numbers. Of these 5 numbers, there are 3 even numbers and remaining 2 are odd numbers. So in this case, the first one, if we add p, q and r and then subtract s and t, whether that sum is going to give you an even number or odd number, that is the question. Here, that is definitely even, that is a statement. We have to verify whether this statement is right or wrong. So here we can apply our trick. What is our trick? See, what we have discussed in our first episode, when we add even number with even, let us say add or subtract, so I am writing e plus or minus e, you are going to get again even number. Similarly, odd number plus or minus one more odd number will give you even number again. Similarly, one odd number plus or minus one even number, you are going to get odd number only. So this was our trick. Okay. Similarly, if you multiply, okay, first let us check this first statement with this trick. So when you add one even number or subtract one even number from another even number, you are going to get again even number. Here in this problem, three even numbers are there. So when we don't know which is even, either P may be even or Q or S or R, whatever, we don't know exactly which is what. So only we know there are three even numbers. It can be P, Q, or it can be P or S, or it can be any of the given letters. So when you add three even numbers, what are you going to get? Again you are going to get, see, one even number plus or minus one more even number will give you one even number. Again your gap, because we have three even numbers here, so again add one more or subtract whatever it is, again you are going to get even number. So the first statement is definitely even, so it is true. So first one is true. Understood? So you have to see like this, whether it plus or minus, when you add E or subtract E from one more E, you are again going to get E only. Similarly, odd and odd. Suppose 3 minus 1 or 3 plus 1, you are going to get one even number. So first statement is correct. What about second statement? Again, see what they have done here, they have multiplied B with 2. When you multiply, I will just rub this so that I will have, oh okay, I have enough space. So I write it in different color, okay, so that it looks nice. Now, what about multiplication? When you multiply one even number with another even number, 2 into 4, what are you getting? 8. So again even number. Then when you multiply one even number with another odd number, suppose 2 into 3, what are you going to get? 6. 6 is what? Even. So one even number into one odd number, you are going to get even again. But when you multiply one odd number with another odd number, you are going to get odd number only. For example, 3 into 5 is 15. So 3 is odd, 5 is odd, again 15 is also odd. So this is second trick in this topic. So apply this trick to the second statement. So 2 into P, P we don't know whether it is odd or even. Okay, so when you multiply odd, either odd or even number with an even number, because 2 is even, what are you going to get? E into E, again E. E into O, see, P is, it may be even or odd. So 2 into even, again even. 2 into odd, again even. So it cannot be definitely odd, this second statement. So second statement is wrong. So answer will be only 1. Statement 1 is right. So this is how you are going to apply your tricks. Understood? So this is a very, very simple trick. Even number, odd number. It looks very simple, but when the complex problems like this are asked, you will get confused. So don't forget this trick. Even plus even, again even. Even minus even, again even. So you write down these simple points in your notebook and keep revising it. Once you become perfect, then you can retain it for lifelong. Fine, this is about odd and even number. This question was asked in, I told you, 2023 Civil Services Preliminary Exam, popularly known as IAS exam. Paper 2. Paper 2 will contain all quantitative aptitude and mental ability problem. So this problem is taken from that question paper. So that is the standard of this question is of that level, IAS level. Okay. So don't say it is very silly thing. Okay, even plus even is even. Everybody knows. Okay, if I divide odd by even, what we will get? If I divide even by odd, what we will get? They are all simple, but you have to work on it. Unless you work, you won't get answers for such problems in exam. Okay. So now let us move on to the next topic in this, even and odd number only. Now suppose I give you, let me write here, sum of, okay, sum of consecutive, okay, odd numbers. Simple thing. Let us say odd numbers, you know, those numbers which are not completely divisible by 2. That means they give you some remainder. So let me write this 1. This is very, very important here, consecutive, because there should not be any gap in between. There should be continuous. So consecutive odd numbers are 1 plus 3 plus 5 plus 7. I am taking up to 7 only. Okay. What is the sum of these 4 consecutive odd numbers? Straight away you can add 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16. So you are getting 16. Fine. It's any primary school class 1, 2 or class 3 student can do this. Fine. Now here trick is, in case of consecutive odd numbers, you count the number of terms. Okay. How many are there? 1, 2, 3, 4. So there are 4 terms. Term means numbers given in this series. 1 plus 3 plus 5 plus 7. So there are 4 terms. Then what you have to do? You have to multiply with that itself. So you are getting 16. Fine, you understood the trick. So if you are adding 1 individually, 1 plus 3 is 4, you using your fingers and all that, if you are not so quick in addition, so you will do like this, 1 plus 3 is 4, 4 plus 5 again, it will take a lot of time. So the trick here is, straight away count the number of terms, 1, 2, 3, 4, 4 terms are there, multiply by itself, that's all, 4 into 4 is 16. So even after individually adding each term, you are getting the same answer. So trick is, count the number of terms, multiply by itself, and what result you are going to get, that will be your answer. Understood? It looks very simple here, but if I ask you 1 plus 3 plus 5 plus, okay, plus 999 up to this, what you will do? In such problems, our trick will help us. Definitely they are going to ask this kind of problem in coming exams, because so far they have not asked this, they have reserved it for future exams. Please remember this and apply, don't forget the trick and apply it here. How are you going to count the number of terms here up to 999? Okay. So for example, up to 10, how many odd numbers are there? Up to 100, how many odd numbers are there? Exactly half of it, right? So up to 10, there are 5 odd numbers and 5 even numbers. Okay, 1, 3, 5, 7 and then 9. 5 ho gaya na? So 5 odd numbers and 2, 4, 6, 8, 10. Ye bhi 5 ho gaya. So up to 10, there are 5 odd numbers and 5 even numbers. Up to 100, divide that 100 by 2. What are you going to get? 50. So that means what? There are, from 1 to 100, there are 50 consecutive odd numbers and 50 consecutive even numbers. So here what they have given, from 1 to 999 is, you can take it as 1000. So next will be 1000. No, so divide this 1000 by 2, you are going to get 500. So from 1 to 999, there are 500 odd numbers. You got it? Fine. So what is our trick here? Multiply that 500 by itself. Very simple. You can multiply. See, 5 into 5 is 25 and there are 4 zeros. 1, 2, 3, 4. Put them in front of that. This will be the total sum of, after adding all these odd numbers, consecutive odd numbers, from 1 to 1000. From 1 to 1000, there are 500 consecutive odd numbers. 1000 is not odd number, but 999 is odd number. If you count odd numbers continuously from 1 to 1000, you have to stop at 999. This will be 500 odd number, consecutive odd number up to 1000. So just multiply that 500 by itself. You are getting how much? Around 2,50,000. This is the total sum of all these consecutive odd numbers. So suddenly they will ask this kind of question. You should be able to write this answer. Okay, there's no logic in adding all these numbers individually. Okay, you are not supposed to do like that, because you may take 1 hour for that. In almost 2 hours exam, 1 hour is spent for this kind of problem. So it is not what I would say. It is very, very illogical. So you have to apply a trick only. So understanding this simple trick is very, very important. Trick, you see, it's not magic. It also has some logical steps in that. How we got that trick and all that. See, this what I showed you, this great mathematician. His work is the result of that trick. Okay. So now I will talk about him in the end. Now coming back to this. Okay, you got this. Understood? I don't think no more explanation is needed. You have to apply the trick. Whenever they give consecutive odd numbers and ask for sum, you have to count the number of odd numbers, okay, given, and multiply by that number itself. You are going to get the final answer. Similarly, what is the trick for sum of consecutive even numbers? So again same, let us take, what are even number? 1 is not even number. Start from 2. 2 plus 4 plus 6. How many? Okay, if I add them individually, you are going to get 2 plus 4 is 6, 6 plus 6 is 12. Fine, for only 3 terms are there, fine. If there are thousands of terms, then your individual addition will become very, very difficult. Difficult means it will take lot of time, and that is not the that's not what you are supposed to do. You are supposed to apply the trick. Let us apply our trick for only these 3 consecutive even numbers. So what is the trick? Trick is, count again the number of terms given. 1, this is 2, this is 3. So what are you supposed to do? You have to, we got 3, there are 3 terms, 2, 4, 6. Now what you have to do? You have to multiply this number with its successor. That means what? 3 into, what is the successor of 3? Immediate next number, that is 4. So 3 into 4 is 12. You got no answer? So this is a very simple trick. In case of consecutive odd numbers, you are counting the number of terms and again you are multiplying that by itself. If number of terms are n, then your answer will be n square or n into n. Here, count the number of terms and multiply that by its successor. That means 3 into 4. So apply for some big problem here. Like how I did for C. 2 plus 4 plus 6. Okay. Plus, let us take up to 100 or 1000 or 100. Okay. Now from 1 to 100, there are how many consecutive even numbers? 50. How you got it? Divide this by 2, you are getting 50. That means from 1 to 100, there are 50 odd numbers and 50 even numbers. I want only the sum of consecutive even numbers. There are 50 consecutive even numbers from 1 to 100 and remaining 50 are odd numbers. So divide this by 2, you are getting number of terms. Now what is the trick here? Multiply this by its successor. That means 50 into 51. So this will give 5 on the 5, 5 for the 25 and 1 0 is there, put it there. If you want up to 1000, again divide 1000 by 2, you are getting 500. So there are 500 even numbers, consecutive even numbers from 1 to 1000. So multiply this 500 by its successor, that is 501. So 5 in 1 the 5, 5 into 0 is 0, 5, 5 is a 25 and add these two zeros in front of this. So this is what? The sum of 500 consecutive even numbers from 1 to 1000. So remember these two tricks. In case of consecutive odd numbers, you have to count the number of terms given and then multiply by itself. You are going to get the total sum. In case of consecutive even numbers, you have to count again the number of terms given and you have to multiply that number with its successor. You are going to get the answer within a minute. Okay. Understood? Is this not wonderful, this trick? When you consider only few terms, it looks very silly and simple. But if you consider up to 1000, up to 10,000, it will become very, very difficult. But with the help of this trick, you are going to get the answer within few seconds. Okay. Now, I'll explain you one more thing, what kind of questions they might ask. See, when they start from 1 to 100 or 1 to 500 or 1 to 1000, it becomes, if you apply this trick, it becomes simple. Then suppose if they give in between, for example, let me tell you, okay, before that I will okay. Now suppose if they start from say 8 plus 10 plus 12 plus up to, let me say 30. What is the sum of these consecutive even numbers starting from 8 ending at 30? Okay, it has not started from 2. So in this case, count again the number of terms. So there are 30 divided by, so there has to be 15 consecutive even numbers. But here it has not started from 2. So up to 8 you have to count to only this much. Okay, if it starts from here it is cut off. Okay, so from 8 to 30 you have to count, but from 2 to 30 there are 15 terms. You have to deduct the terms before 8. So how many are there? Again divide this by 8 by 2, you are getting 4. So this is the fourth term. Understood? So from 4 to 15, how many terms are there? We just subtract it and you are getting 11. So there are 12 actually. So 12 terms are there from 8 to 30. Okay, because 2, 4, 6, 3 you are deducting, so 15 minus 3 is 12. So there are 12 terms from 8 to 30. What you have to do, you have to count again. This from 15, this, since it is even number, you have to multiply with its successor. 15 into 16. Whatever you are getting, let it be there. From 2 to 8, from 8 we have counted here. So from 2 to 6, again you have to count the number of terms. 2, then 4, 6. So 3 terms are there. 3 into 4 is 12. So you have to subtract this. You have to subtract this from this. Whatever answer you are going to get, that will be your final result. So if they give some problems like this, taking the consecutive numbers from somewhere, not starting from the first term, then you have to follow this method. Understood? I hope you have understood. Remember those two tricks, and they are really very useful for your exam. Now coming to Carl Friedrich Gauss, German mathematician. See, mathematics is known as Queen of Sciences. Okay, Queen of Sciences. But this person, a great mathematician of 19th century, 18th and 19th century, because he was born in 1777 and died in 1855. Okay, so he was known as, of course, he is known as Prince of Mathematicians. Okay, mathematics is known as Queen of Sciences, but this Carl Friedrich Gauss is known as Prince of Mathematicians. So his contributions to mathematics is really wonderful. This trick is very he when he was, his parents were very poor and uneducated, but luckily he went to school, and after his 7th birthday he went to his first school, and that school was run by a teacher called Butner. Okay, Butner was very terrifying teacher. He used to teach mathematics. His only aim was to thrash students, terrorize them. So that was his style of working. He was infamously known as terrorist maths teacher. Okay, whatever it is, and during his first 2 years in school, nothing significant happened. But when in his 10th year, third year of his schooling, he was admitted to arithmetic class, and Butner was the teacher. So Butner gave one problem to students. He asked them to find out the sum of first 100 natural numbers. These are all natural numbers. 1, 2, 3, 4, counting numbers, whatever we say, these are all natural numbers. 1, 2, 3, 4, 5, 6. So he asked one difficult problem. It is simplified here just to make you understand the thing. So he asked the students to find the sum of first 100 natural numbers. That means 1 plus 2 plus 3 plus 4 plus 6 plus like that up to 100. What are you going to get? That was his problem, and all students were busy with nobody was right in their answers. But Gauss, within 2 minutes, he found the answer and gave it to slate. They used to write on slates there. So he gave his slate to the one great Butner. He was very astonished. Butner, the teacher, he looked at his answer. He hardly followed just 2 steps. Okay. And he has come up with correct answer. It was, see, the teacher like Butner, who was known as a terrorist. He was He was astonished and he said, Carl, or whatever Gauss, oh boy, hey boy, you are beyond me. I can't teach you anymore. These are the words of Butner. Okay? Because he used a very, very simple trick to find the answer. What he did, Gauss, what he did was very, very simple thing, but a boy of 10 years old, that was really, really astonishing. Okay, after knowing this, it looks very simple, but how he was able to use this trick, that is really wonderful. So this is, see, he was just 10 years old that time. What he did, he just wrote these numbers, okay, up to 100, and again he started this from here, 100, 99 plus 98 plus up to 99 and so not 99, 2 plus 1, and he added those two. He got 101 plus 101 plus like that 101 plus 101. So he got 100 101s. Okay. He multiplied it and he got this answer. And he divided it by 2 because he has considered one row extra. He wanted only sum of this one. So he divided by 2 and he got this answer, 50, 50. So this is Carl Friedrich Gauss. Okay, a boy of 10 years old, he did this. It was magical. A teacher like a terrorist teacher like Butner, he was in full praise of Gauss. Okay, and Gauss, what he did after his school and all, he became great mathematician. Okay, so all this wonderful history, because now I don't have time to talk about him. We'll definitely talk about him later. Like Pythagoras, Gauss is also a wonderful mathematician. That is how he was known as Prince of Mathematicians. Okay, now I'm going to end this here only. In my next mathematics class, I'm going to tell you about how to count triangles and all those things when they give in your exam. Okay, like this, something was given, find out how many triangles are there in this diagram, something like that. That kind of questions are asked in all SSC, bank exam, even almost all competitive exams. So there are some tricks. I will teach about all those tricks in a different way so that you will understand it in a better way. Okay. So you remember how many tricks I have given to you? You just list out, make a separate notebook and write down in your own style. It is going to become a big resource book for you. Okay. Fine then, see you in my next episode very soon. I am signing off with saluting Mr. Carl Friedrich Gauss. Okay, he is one of the most favorite mathematicians. Okay. Thank you very much. See you soon.